All right. So now, testing one, two. It seems like it's working. Okay. I can see. Yes, we're live. I'm just gonna post this in case somebody wants to come back from LinkedIn. Let's see. We're back for around 2 hours. But yeah, what is this? This is like after lunch. We're back for 2 hours of afternoon chill. Let's see. Perfect. That was pretty fun in the morning. We didn't get any real progress in the task, but or I mean, I guess we did get some, but it was fun to see some familiar faces joining online. So, hey, uh, the round went great. In case you were wondering, I can imagine that sounds a bit strange now. So I'll have to. I don't usually drink this thing. This like what is it? What's it called? Liquid foods. But I'm gonna go help some friends later today to move um, into yeah, they're gonna move to their new apartment, so they're gonna buy me pizza for helping out, so I don't want to eat too much. mm. So we're just drinking something light, so yeah, let's jump back into it. So the task here we're trying to solve was with the right we're in the submarine at the bottom of the ocean, and we are trying to figure out. We have some scanners and we have some beacons in space, inside, like in the water, and we're trying to figure out where the beacons are, so that we can navigate through the space without crashing on things. So the problem is we don't know the alignment and the location of the scanners. Um, and so we have to figure this out by checking among the scanners how many have at least 12 beacons in common. So each scanner finds listens to beacons in its area, and it gives us a list of beacons, and they kind of look like this ish. That's a poor approximation, but I'm basically looking at the orange ones are, let's say, maybe I can write this down. But here, yes. So let's take this color and say, let's write um, scanners. Let's make maybe this a little bit larger, and not that it really matters, but we're wasting time always. Uh, so let's see, and then we want one here that is beacons. Oh no, that is the wrong color. Totally. Choose the. Can I just take the? No, what? That is strange. Perfect. I want beacons. Yes. So basically, our scanners listened for beacons, and they found some beacons, and they kind of overlap at some points, and we want to figure out when they overlap, if we can find that they have at least 12 beacons in common, and then we can know, let's say, let's refresh our memory here. Um, mm-hmm. Mm, by finding pairs of scanners that both see at least 12 the same beacons, you can assemble the entire map. But what I'm failing to understand is how I match them. So, so thing what they did here is, so they've created all the possible different alignments for each scanner. In total, scanner could be in any of 24 orientations. For example, here's an arrangement of beacons as seen from a scanner in the same position but different orientations. Yeah, so it's just different minus and plus signs everywhere. Why is it 24? 24 different orientations. Oh yeah, because it can be facing. Wait, what? Due to magnetic alignment, each scanner is rotated to some integer number of 90 degrees turns around all of the X, Y, and Z axes. That is... one scanner might call a direction positive, while another scanner might call that direction negative. Or two scanners might agree on which direction is positive, but one scanner might be up, facing, upside down. So anyway, I think I'm having a hard time really visualizing how the scanners look like. So when I was running, I thought maybe we should step back a little bit and just look at how the scanners look like. So I'm gonna try to use a really sweet library I like that has also very interactive 3D plots, and that is Plotly. So import Plotly dot. Oh, I don't have it installed. Okay, let's fix that. Poetry add Plotly. Hey, welcome on the stream. Let's see. So now we want to use. Hopefully that's gonna be fine. We want to use Plotly because it helps us do interactive plots. And we're going to be able to navigate a little bit the space and see how the scanners and beacons look like, rather than having to base it off my highly inaccurate Photoshop animation or here, like drawing here. So let's see. Okay, we're getting these installed. In the meantime, what are you up to? What is your day like? I can see the chat, so if people feel like writing something, go ahead. Hello friends. There you go. You get a heart. Everyone gets a heart. Oh, Plotly takes a while. Let's see. Oh, wow. Okay, until this installs, let me just look again through this. So in this case, yeah, we were shown these two scanners in that first example. So how? If you print them, so basically, what if you assume that scanner 0 is in the 0 is in the center of it's among all these, then basically what they do here is just plot this like this. So 0, 2 is this one up here, 0 is the scanner, 2 blocks away is a beacon, 4, 1 is 4 is here. No, sorry. 4 is here, and 1 is that's strange. That is definitely not 1. 3, 3. Drawing X increasing rightward, Y increasing upward, scanners S and beacons B. Scanners usually text this. No, does it? 0, 2 is 0, 0, 1, 2. 4, 1 is 0, 1, 2, 3, 4, 1. Yes, it's this one. And 3, 3 is 3 is here, and 3 up there. Okay. So then the other scanner is itself in the zeroth, like you see in the origin, and we see that this one here is seeing, okay, -1, so it's on the left side down. So it's this one here, the beacon. Then we have a -5, 0, which is on the same x-axis, but y-axis, but to the left, -5. And then -2, 1 is this one here. So we have this picture here. So I can see already one thing between those two grids, that there is some sort of alignment that you could say, if you could try to overlay one over the other. The problem is, you have to know how to align it. And later we hear that we actually don't have the scanners aligned at all. So that's a bit of a deep problem here. At least from my skill level, I feel like, or I'm missing something. So this example assumes scanners only need 3 overlapping beacons. Then the beacons visible to both scanners overlap to produce the following complete map. Yeah, but then this overlapping here happens with knowledge that all these beacons overlap, or are the same beacons for both scanners. So if we know that, so then that is maybe the first thing we have to solve. So the second problem is that we don't know the orientation of the scanner. So maybe what we should do is, instead of what I was trying to like kind of hack it around, what we should do is to try to figure out if there is an optimal, if we try to somehow, I don't know exactly how now, but if we try to somehow match all the pairs of the grids of scans in such a way that we can align at least 12 beacons in each. I'm not sure how I would go about solving this way. So that's why the first thing I want to do is to just okay, Plotly is installed, so let's restart here. I actually always like plotting things first. Yeah, so let's see now. So we want to do Plotly Express as px. Usually that's how I import it. So Plotly Express is just like a quick, faster version of Plotly. Faster in the sense that you don't need too much effort to create visualizations. But for that, we will also need, I think we will need pandas as well. Perfect. So if we go down, if we run everything actually, okay. So where we create our perfect, we have the coordinates for the beacons. Yeah, we can start ignoring this information here for now. So let's create, let's add a few empty cells here, and just I'll just write here that this is old approach with pairwise distances. So we don't want to come back here yet and for a while. Let's try this new thing now. So we have the beacons, and we also have the scanners. So let's try to make a data frame that has, or can I try to concatenate np concatenate. So concatenation just put things like join two arrays in a one. So what I want to do is I want to take the beacons and the scanners and merge them together. Let's see how that will look like. Okay, that did not work. All the input arrays must have the same number of dimensions, but the array the same number of dimensions. This has one dimension. Okay, but can I do axis 1? No, 0. Okay, what? That's strange. Okay, yeah, I see what the problem is. Can I do this? PD concatenate? Maybe pandas can solve this for us. Maybe they've implemented something nicer. So we want some iterable, and that is going to be our beacons and scanners. That failed also. I'm just gonna blindly test if the issue was the direction we're joining them. No, it's not. Okay, that's a different problem. It doesn't like the numpy arrays. But let's do. Okay, we have the beacons like this, and I just want to add. Okay, I know what's the problem. So we also need to make the scanners have a similar number of dimensions. Nurse. Okay, so we want to reshape that into 127 by 1. Yes, so perfect. So now what happened is that we basically made like a tiny array, like we literally reshaped our array. I'm a little bit unsure exactly of how this magic works, but as long as you give an input behind the scenes, I'm not sure how they do it, but if you give it dimensions for a resulting array that you want, so maybe so in this case we had this, right? So our current shape is 127 by nothing, so it's a one-dimensional array. But if I tell it that, oh, I want you to make this array, reshape it into 127 by 1, so then it's going to make it a two-dimensional array by basically taking every element and making it its own column. Creating a new column that contains one element at a time. So this becomes basically each element becomes a list. So if I would do this, I think that should not work, right? Yeah, because we would need. So we would need double the amount of values inside our array to actually make that happen. So let's take this, reshape it like this, and let's try np concatenate again. So we want to concatenate our scanners and our beacons. So let's do that. No, okay, something. Okay, I have one parenthesis too few. An array programmer for the concatenation axis must match exactly, but long size 1. Okay, maybe now this is the problem. Yes, okay, perfect. So basically, this axis means in which direction do you want to concatenate the two arrays, and by default is 0, which means that it will try to put the beacons array on top of the scanners array, but we actually want them to do side by side. So this is going to be that usually is denoted as 1. So yeah, so now that we have this like this, we can call this bacon. No, beacon. I'm really bad with naming sometimes. Most times, I guess. So I want just to be beacons, scanners. Yeah. Anyway, so we have everything together, and I'm just going to. I like to usually visualize things at least for a while. So I'm just going to print the first 10 rows. So we see how it looks like, and then we make a data frame from this. So this is going to be beacons. I see what is happening. This pop-up is coming up. Can I take it away? Because it's hiding my suggestions. That's annoying. Beacon scanners. Okay. So if I run this like this, then it will perfect. It creates this table here, but we want it to be. We want to give the columns names. So we want them to be X, Y, Z, and scanner. So now that we have, now we're gonna call this df for data frame, and just df head to show the first 5 entries. Perfect. And now we're gonna take plotly px and do a 3D scatter plot. So what I need first in the 3D scatter plot here is it does not. Okay, that's strange. But anyway, I kind of remember what we need. We need the data frame first, right like that. Then we need the x to be x, y to be y, and z. Oh, there's no z. What is it? No, it is z. Okay, z. This one to be z. So basically, we're telling Plotly to which dimensions are which columns in our table. So now I also want to use an extra dimension, and that's the scanner, and I'm gonna give it the color dimension, and that's scanner. So let's see what we get from this one right away. Ooh, it's staying a while. Oh, nice. Yeah. Wow. So we see, and that's the best feature about Plotly. Look at this. We can just like move it around. So my problem now is that I think the bubbles are too large. So size maybe? Size. Yeah, size 1. No? Okay, what is the problem? Well, size is not the name of a column. Ah, okay. No, but I don't want it to be. I want it to be. Doesn't matter. Okay. Or maybe we can quickly check this out. Plotly. Hello, friends. I see. Welcome to the stream. Plotly, Express, Scatter, 3D. Oh, sorry. Strange days. I promise you can't get sick over the internet. Let's see now. We want the size. It takes an integer. So what's broken here now? Either the name of the column or a panda series. Values from this column are used to assign to mark. Okay, could be. I don't know why it would take an integer. But I want it to be. I can see the chat, by the way. So if you wanna say hi or ask questions, go for it. Let's see, labels. No, I want to set the size, the maximum mark size. Okay, when using size, I want to set the size of the bubble. I don't want it to be larger than a certain size. But I guess here it says that we have to be using the size variable. Okay, so maybe what I could do is we could hack it. Why not? We can just add an extra column here that is going to be our plotting size. Let's see. Should I do it like this, or maybe one last look? Maybe we can find it. Custom hover size. That's a bit annoying. Yeah, no, it seems like we'll have to bake it in our data. So, we can do this. Let's see. Let's add an array that is. Can I do this? No, because the dimension is not. Okay. So let's create a new ND array. The array. Can I give it a default? It takes the shape. Array should be constructed using an array, zeros or empty. I want it to have ones. Okay, wait. I have another idea. So I think we can do this. If I do, will that make this 10? Yes, perfect. So look at that. We can hack it. Python is such a funny language. So we can actually tell it to multiply the number of arrays we have by 10. So then it makes this one into an array of 10 ones. So let's make this one here and multiply it by the number of the shape of our beacons. Beacons shape 0. So that means we take the number of rows our beacons data has, and create this. So if I and create so many ones. Will this work? No, because it needs. Oof, that's gonna be looking very ugly. Excuse me for that. We want to make this into an array, and we want to reshape it into. Oh wow, you're gonna hate me for this. Into the size of the beacons, with comma 1. And I realized that I baked this in here as well. 127. We want to instead have the size of the beacons. Wow, this is really hard to read. Okay, let's fix this. So we're concatenating the beacons with the scanners and this other array we're making, which is reshaped, blah blah blah, and then this one here, and this one down here, and that's where it really ends. This concatenation. So let's see, and I can maybe put this in here. So mate, what do you say? Maybe that looks a little bit nicer. Let's see if I run this. Perfect. So we see what I did now is that they just added an extra column here, which we're gonna name size. So we can control the size of the bubbles in the plot. Speaking of premature optimization of things, size is going to be size, and let's see how that goes. Oh wow, did it really? Oh yeah, something happened. Okay, perfect. So each color, so we have 4 scanners, and we can see that each one of them. Wow. So what is the pattern here? So we see the yellow ones, like none seem to overlap, which may be reasonable actually. So let's see, can I filter for each scanner? Can I click on it? And no, I can't. Okay. I remember I could do that. What is orbital rotation? Sounds pretty. Wow. Sounds pretty cool. Right. So what we're looking at now is the beacons that have been scanned by each scanner, and scanner is what I'm going to do an extra thing. I'm going to make the scanner column into a string. So df scanner is going to be equal to itself, but as of type string. And if I run this again and this again, we should see now perfect. So now we see that each scanner has a distinct color instead of a gradient. So now we can actually do what I was wanting to do. So we can, yeah, perfect. So we can look at one scanner now. Let's look at scanner 0 and scanner 1 together. So it seems like it feels like these 2 points are really close to each other. So if I zoom in a little bit, it feels like these maybe are the same. So we could somehow say, okay, let's match these 2 together, and then everything will, like all the dots will come a little bit closer or further apart. And then we want to see, okay, I think these up here, they look a little bit symmetrical. Maybe they are the same. Let's see. navigating this 3D space is not the easiest thing. Oof. Um, let's see. Yeah, I suspect they are the same, depending on which angle you're looking at them from. So mm, wow. Okay, I'm not sure if looking at them increased my intuition about solving this problem. Hmm. So maybe we can try to subtract all. Uh, let's see. Let's look at this at the problem again. So they gave us this coordinates for the example coordinates. Oh, hey Gabriel, nice to have you. This graph looks so nice, thanks. It's literally just a base plotly. I didn't even like augment the like preset of plotly here. Honestly, just took the scatter 3D function from it and plotted as it is. I guess the tricky part here is to know how to represent the data so that they appear correctly. Like yeah, it's how's like you have to know that okay, if you want them to be categorical, you actually have to make them strings in this case. But if we've used this kind of representation in real applications, I've used it in some sort of dashboards before, I would say, and I've actually used it once. Yeah, when I was a consultant a while ago, I actually used this library to in a web application because this is actually what we see here now is rendered inside a web page, basically, um, under the hood at least, and so I was serving this as a web application for some like an architect firm, so they had like a cluster of objects that they wanted to figure out like they basically wanted a recommendation engine. So they had a cluster of objects in space, and they were like, okay, if I click this object here, what recommended objects do I get to add in its vicinity? So we're doing like a fun proof of concept thingy. It went pretty far, I would say. It was pretty fun, but yeah. I think the issue with Plotly is that maybe it's a little bit heavy, but they have yeah, it has a kind of a limit in how many plots like points you can plot. But let's see, they have Plotly Dash, which is a relatively new dashboarding thingy. They support quite a lot of languages. I think they also support MATLAB, and you can let's see, yeah, you can create dash apps, what they call, which is basically dashboards, yeah, kind of like this web applications that have interactive visualizations. So I would say it's pretty cool to like dive into a little bit more. Yeah, thanks for the question. Let's see. So now the problem I'm running into is we want to figure out. So some of these points between the red and the blue ones are common, and we need to figure out a way to rotate and move all these points together so that they eventually match, or some of them will match at least. If we look again at the, let's see, at the example. Let's see, what's the time? Okay, good. Right, we need to find pairs of scanners that both see at least 12 of these beacons. You can assemble the entire map then. Yeah, okay. So this is an example scanner. So I've actually copy pasted this data in. So this is the data we're plotting for these 5 scanners from 0 to 4. And all these positions are relative. So every scanner sees its environment for itself. It does not know where other scanners are. So in this case, they use scanner 0 as the origin. So I guess the simplest way to do this, to like simulate the same thing, is to just subtract um, the scanner one, the the coordinates from every other scanner, including scanner from scanner zero, including scanner zero itself. But how? So the other problem is that they are not aligned in the rotation axis. Let's see, scanner 0 to 1 are overlapping detection cubes. The 12 beacons they both detect relative to scanner 0 are those coordinates. Yeah, but they don't solve the rotation here. Scanner 9 is relative to 0. Following this process, scanner 2 must be at. Okay, and then they're extracting out the full list of beacons. So we need to just figure out the full list of beacons, and I tried to hack this in the morning, but very quite unsuccessfully, sadly. So now maybe we have to actually implement the proper thing. So let's see. Let's start by just subtracting all the dimensions from. So what I will do is for this data frame, let's take the rows where scanner, let's see, df scanner is equal to 0. Actually, that's a string, so we want to be like this. So basically, this returns all the coordinates of beacons that scanner 0 has seen. And let's make this and then what we want to do is subtract this from every other. So for scanner in I'm just gonna take this in scanner, so we take the scanner column and we just take the unique values, so we loop through them, and we want to so we want to basically do this. So for the current scanner, and actually only the X, Y, Z columns, we wish to subtract. Okay, let me take this again as well. So we take only these columns, and we wish to subtract the scanner 0 from every other scanner. So let's take a copy of that here. Perfect. Let's see, I'm going to make this a little bit nicer. So we want to subtract this from this, and closing that here. So if I run this once, we should see that. Perfect. So basically, oh no. Yeah, right. So we don't, because now basically all the points of scanner 0 obviously became 0. So we want to skip scanner 0. So if scanner is, so let's actually set origin scanner as 0 for now. So let's go down here and change this to origin scanner. And then I want to say, so if the scanner we're currently looking at is equal to the origin scanner, we actually want to skip it. So continue, we'll just do that. We'll just go to the next iteration. So now, because I already overwrote my data frame, I want to recreate it. So we go one step back. So we get back the coordinates. And now, okay, so actually, let's do this. Oh, let's do this again, but only look at the, maybe or okay, it probably doesn't matter to show anything here. We won't really see anything. So let's try to plot this. Oh, that is interesting. Wait, what happened now? Something strange happened because now we only see values for the scanner 0, while the other scanners still exist as well. Let's see. DF. Let's just plot. Show it. Ah, okay. Wow, they became not a number. Huh? Why? That is strange. Let's run this first one again. So, and just make sure. Let's check the. Oh, hey, Yordbad. Sorry, I'm solving the or attempting to solve the Advent Code Day 19. So it's a puzzle thing. There's a new coding challenge every day, from the 1st of December to the 25th. And every day we get this kind of puzzle that we have to solve, and then you get stars for good job, you solved it. So now today I'm doing day 19. I kind of skipped. It's a little bit. It takes quite a bit of time, I realized, to try to solve these, and so I haven't been very keen on doing that. But I thought maybe it would be fun to do it in a stream and with whoever comes by. So thanks for stopping by, your bear. So basically now we have a list of beacons that's our scanners scanned in the deep ocean. So we're inside a submarine, and we're trying to figure out where we dropped our keys in the ocean. So at this point, there has been a few other tasks in the past that we had to solve. The current one is we're so deep we can't see anything. We deployed some beacons and some scanners, but the problem is that we don't know the location of the scanners. We only know what they read, so it's the location of the beacons in relative to their own location, which we do not know. So that's also one thing we need to figure out. And the way to figure it out is by, I think the data set is crafted in such a way from the creator that at least 12 beacons will eventually overlap somewhere. So now where we are now is I'm trying to figure out a way to solve this. In the morning I tried to kind of hack it, because the only real answer we need is how many unique beacons there are. But that didn't go very well. So now I'm gonna try to I'm trying to get a better understanding of the problem. So I started with plotting things to see how they look like. So let's so what I wanted to see here is right, I just wanted to make sure that our data is in the correct form. So yeah, XYZ is integers. And these are objects, so we don't care about size, scanner and size columns. The other ones are integers, and there is no null values actually. It's 127 field values. Something strange happened when I run this here. Let's try to run all this again. Yeah, they become not a number, which is strange, because this one here should always give us the origin scanner, right? Yes, perfect. And actually, I'll change this one here to 0 just to test this out. Let's run this one again so we get the data back. So number 1 is like this. So if I would just attempt to subtract one from the other, so subtract the 0th scanner data from the first. Oh. Wait, okay, so that. Oh, I have an idea what may be happening. Okay, yes. We each scanner sees a different number of beacons. So we can't, right? Probably. I think that is probably the case. Let's see. Because that did not work here. Oh, where did it go here? So what is number one? It's this one here. Or maybe it's trying to perform some operation with the. What happened here? No. So how many is? Let's try the shape of this one. It's 25 by 3. For 0, it's also the same. For 2, 26. Okay, that's a problem. 25 and 26. That's a problem. Okay. Yeah, because if they're not the same size, then how do you correct? So basically we have to find the middle. Yeah, we have to find the middle point of the. Yeah. So what we have to do? Okay, I got an idea. So what we have to do is we actually have to find where our scanner lies among these points. But if we do, let's see here, because what they do here is they all coordinates are relative. All positions will be expressed relative to the scanner using the orientation of the scanner 0. Yeah, okay. Okay, I'm not really following here. All absolute positions will be expressed relative to the scanner 0. Okay, so these positions given here are not relative to the scanner 0, though. They are relative to scanner 1 because they do not know each other's locations. Scanners 1 and 0 have overlapping detection cubes. The 12 beacons they both detect relative to scanner 0 are the following coordinates. So we have to find a way to subtract from those. No, but I think they're just skipping the details here on purpose so that they don't give us any hints. Because they don't say how you go from relative positions to absolute positions. Because of this, scanner 1 must be at relative to scanner 0. Yeah, because once you figure it out, these are following coordinates, but these coordinates are for, I remember I checked that this morning, they were for scanner 1, 0. Right. Yeah, it's this one here, for example. And where was this one? That's also going to be there. Come on. No. Okay. That's one. Okay, it exists. Wait, where's that? Oh no, that's the full list. Okay, we don't care about that. No, this is over there. So this. So how did they figure out they are overlapping? These 12 beacons in the same order, but from the perspective of scanner 1. Right. So this is the first. So this one and this one are the same, but from different perspectives. But how do you match them? That is the real question. Because when we look at our so when we plot everything at the same place, so if we just skip this this step here and just yeah, let's do this one again. Just run this so we get the correct the previous representation. Let's see, yeah. So we can definitely see that all of them have these clusters. So you can tell, right? There's clusters up there in the corners and in the middle. So the data is crafted to not be hard. Which, yeah, thank you for that. But I wonder if we just have to take like just flip the data enough times. So we take scanner 0 and 1 and we flip the data of scanner 1 enough times until we have some measure of some way to match. Do you have any ideas? Right. I'm failing to see how we will make these overlap, because they are also they're not centered either. Also, they all have like two, okay, what I'm gonna do instead is try to actually do this, like take multiple copies of scanner 1 and change the orientation enough times. But what was confusing here is they say that what was it here? In total, each scanner could be in any of 24 different orientations, facing positive or negative X, Y, Z, and considering any 4 directions. Up. Oh, yeah, okay, that's also as if it wasn't hard enough. We don't know. Okay, that's a good tip. Thank you, Gördbert. To change the coordinate system to a standard coordinate system with basis 1, 0. Right, so... Oh, wow, yeah, you're right. We need to switch to unit... yeah, what's it called? Wow, university times are flying out of my head. Zero mean, and unit variance, I think, right? Hello, Nico. So that S1 is defining the standard coordinate system. Yeah. Right. So the way I would do that would be to figure out the mean, where is the so that all the points go back to like the origin. So that would be yeah. So we need to figure out the average position of all the points. Subtract of each in each axis. Yeah. So we would need. Yeah, that's what we need. Can we do that in a cool way in pandas? Well, yeah, actually we can. So we can do. Uh, let's go back here. Thanks for the tip, Nico. Um, so we want this one for when. Okay, let's take actually the location. So we want for the data frame of the for the scanner one 0. Sorry. If we take the x-axis and we take the mean of that, we see that's the mean of this one. So we will need to subtract this from all the points to move them back to the origin of all the x-y axis points. Then we want to do the same for y and z. So let's see. And then we also want to fix the variance. Wow, I haven't done this in such a long time. But I remember it was actually a machine learning class because we had to normalize our data. Yeah, exactly. That was the keyword. Wow. I wonder if we do need zero variance. Unit variance. Sorry. Yeah, no, we probably don't care about unit variance. No, because all points are in physical space, so it's not like it's going to be an issue. Right. So that's pretty cool because what we can do now is just say, okay, for all x's, perfect. Just subtract the mean of the first scanner everywhere, and do the same for the rest. Axes. So let's make this y and this z. Oh shit. Z. Yes, perfect. So let's see how that. So let's skip this one for now. We don't want that. So we can also skip that for now. Let's see. Let's make sure we can see things here. Okay. So. I'm not sure if we did change much. So they are probably. Because from the beginning, all the points were. Let's see. I didn't mess anything up here. Okay. Wait, am I thinking this right? Whoa. But I'm assuming that. Okay, I'm doing some laps of thinking here. That's going great. Right, so I probably maybe the mean is not enough to fix. So how do we? Let's figure this one out. I appreciate the tip. I think I have to follow that one. According to the scanners to be a standard coordinate system. So how do we do that? How do we switch? How do we switch the coordinate to a coordinate system? Let's figure that one out. Let's see. In a point cloud or something. That seems interesting. Oh wow, yeah, it's no, okay, that's probably something that is automated. Right, yeah, never mind. No, that's for Revit. just flipping everything around. Um, I do have this vague memory of 0 million unit variance being the all the shit for fixing the origin. Um, but I wonder if we do need the variance fixed as well. No, I don't think. No, we don't need the variance fixed. No, because this is a. But at least we do. Now we should have. Let's see. So we should have the switched our coordinate system to the first scanner or the 0th scanner. Okay, I'm hitting another wall at this one. I see. So maybe, so my initial plan or my previous plan was to then take. Maybe we can still try this one out. So we take scanner 0 and 1, and we make scanner 1 flip a few times and print that. So let's try to do that after we fix the mean. Let's take these cells further away from here. Down here, so we don't mix them up. So yeah, so let's take so we want to make each of the possible coordinate systems for, or not systems, but possible orientations for scanner number 1. So we have three. So we want one case where everything is. So we basically make minus x and we keep z and y. One where we have x, y, z, right? And then let's see, perfect, minus z, and then we want also all the, okay, so that will be maybe, no, that should be, yeah, it's 2 states, yes, or so we need, how do we do this in Python in a nice way? We want to flip each coordinate once. Right. Because then we want to do this one as well. I'm thinking. Let's see. So then we need all these combinations, but we need to make them programmatically because we're not going to do this manually. Maybe. Oh, wow. This problem might be a little bit all outside of my skill set, mathematical skill set, maybe. So let's try to figure it out either ways. So we want to be adding. So what is the pattern here? We start with. So maybe I can make an array of 1s, and iterate through by switching which one is negative, and then um, multiply the initial coordinate system by that, so that we flip everything. Right, so first we start like this. And how do I move this nicely in each? Can I shift? Can I do? Oh, wait, click here. Shift? No, we can't. What do we get? Insert index and reverse. No. Can I shift tuples? No, I don't think so. No, we get even less actually. I wonder if you can do that in Python. That would be pretty cool. Can we do shift bits? Shift Python list actually. Okay. Sure, yeah. Insert an element in the beginning, and then I don't like that. We have to have a cool way to do this. I don't want like elegant things. I don't like this. So basically, what they do is just they take the same list, insert an item at the beginning, and pop the last item out in one line. That is relatively nicer, at least. So it takes the left item, the last item, and puts it at the beginning. Okay, let's test this one. Then we have test, test, insert, test, pop. But it always pops the first item, right? Yeah. No, append. Sorry. Oh, but we don't get it printed. Okay. But now, yeah, I know what happened. No. All right. So now, yeah, now it moves. Perfect. So we got this. But we let's see. Oh, I just realized the stream is using surprisingly little CPU. It's only 7%. That's nice. All right, so we have this, so we can make these ones. But what we want to do is, but that goes also the other way around. So maybe we can take the inelegant version. Not that it really matters, but so brain damage. So what we want to do is once the last one reaches -1, we want to make it stay at -1 and and keep the other ones. Make the other ones keep populating. Okay, I'm starting to think that maybe manually crafting this would be much faster. Or can we? Well, could also be. Can we do it in binary? Can okay, wait. Python binary. Let's see. Because because what we could do is we just increment int. Yeah, so we take integer to binary um, list maybe. Let's see any good idea. Oh, here we are. Okay. So they're formatting a. Oh no, but this is not a string. This is a. Okay, it is a string being formatted to binary. Okay. And you can even do this. So it's for. Wait, what is formatting here now? So this is 0. It's been formatted to 8 bits, but this is not 0. Ah, sorry. Yeah. Oh no, never mind. This is the 0th entry in format. Yeah, this is an old-ish way in Python to do this. So what we want to do then is we want to take an F string, which is the modern way of doing this. So if I take number 2 and say I want it to be binary. Yeah, there you go. Oh, that's so cool. So basically, oh wow, that's gonna be so nice. So we can say this for I in range 10, and I'll change this to I, and you'll see. Ah, perfect, nice. So awesome. So now what I actually only want 3 of them, and we only want to reach all the way here. So basically, either none is 0, or 1 is 0, or the middle one is 0, or the other one is 0, or the other one, so and so until everything. Sorry, not 0, negative or positive, so that we change the orientations. So let's make this here 8, and so we got quite a few combinations here. So the initial combination is going to be right. So what I'm gonna do here is I'm going to replace 1 with -1. Yeah. Okay. That's very hacky. Okay. And then I also want to replace 0 with a 1. Okay, we're getting somewhere. Okay, actually I don't want to do it here. No, we want to do it. Let's see. Let's go back here. All right. So basically now we have our first initial rotations of each axis. So this is the standard rotation. There's no rotation. This is the Z axis is rotated. This is the Y axis rotated. This is both Z and Y. This is only X. This is X and Z. And this is X and Y. And this is all of them. So I think this covers it. Yeah, so I think this should be. So now we have 8 of them. And then we also have the, what is it? We don't know what's up and down, basically. So yeah, that I don't really understand how people solve these so fast. So we have these leaderboards with some friends, and I have these folks that solved all the problems so far super fast. They wake up 6 in the morning when the problem appears and do it. I feel like I'll be spending the entire day doing this, and I actually even can't. I have to go out. People are pretty good at this. Let's see. Orientations. Yes, we got them. So we can remove this one. We don't need it anymore. We can start with these basic ones and let's just look at them. So what I'm gonna make here is orientations. And you can also print it so we can see how it looks all the time. It's nice to see things. Orientations should be so what we're gonna do is gonna loop through it again um, in a string, like a string list comprehension way. So let's say or in orient whatever, or xyz xyz for xyz. Oh, come on. In orientations. So this will just read those, and what we'll do is we'll split this for each. So no. Wait. Can I? No. Okay, but what I can do is I can nest another list comprehension here. So what will happen now is that in Python you can have the strings are basically iterables as well. So you can iterate through each character. So what I'm gonna do is I'm gonna iterate through each character, and I'm gonna say, what should I name this now? Good luck. Variable naming. I mean, it's one coordinate each time. So coordinate for coordinate in the string xyz. Maybe that makes sense. So then, perfect. Then that's how this looks, which exactly is what I wanted to make. And now what I want to do is, if I want it, if it's zero, if it is replace 0 with 1, and replace 1. No, sorry, we need to do that first, because otherwise everything is going to become -1. So we need to do -1. Perfect. And now we also want to cast this as an integer. And look at that. Wow. And make this a NumPy array. Is that complicated enough? And let's look at this beauty now. Wow. And we have a great array to iterate through. So this is going to be our coordinate flips array. So we're gonna iterate through all of those and multiply. Okay, we got it. It's happening. So we're gonna iterate through all those, and in this like super ugly, compact, unnecessarily compact list comprehension. I'm gonna try to just make it a little bit prettier. So basically, it loops for every orientation and unpacks the orientations into each separate coordinates, replaces zeros with ones, and ones with -1s. So now we have these to multiply each of our axes on the scanner 1 to make it flip and make this plot a little bit more interesting to look at, hopefully. So for flip in chord flips, we want to multiply. Let's first test this outside. Let's take location of wait, I maybe have it saved in my clipboard. Location scanner. Yeah, I do have something here. Let's see this one. So let's test this. Multiply this by the coordinate flips. Let's take the, what is this one? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8. Wait, huh? Yeah, okay. I don't even know how to count anymore. So basically what should have this should have done now is that it should have flipped everything around. So if I just also print, let's take this an extra thing here, import IPython or from IPython import display, and this is nice because it lets us print these interactive things multiple times. Let's see where we beacon scanners now. We're further down here. Perfect. So we wanna display this, and we also wanna display, and just maybe, and not all of it, maybe just the head. And let's do the same for without multiplying anything. Okay, I messed something up with. No? Module object is not callable. Module what? Wait, what did I mess up? Ah, okay, wait. I think that's the problem. It's easy, obvious to spot, right? Okay, yeah. Obviously not. No, that was not the problem. Okay. So maybe it doesn't like to display these things. Let's see. No, that worked. Okay. So what happens if I do display? Ah, it doesn't work with head, maybe. No, module object is not callable. What? That is strange. So display is not acting. Public API for display tools. Oh yeah. It's I imported. Yeah, it literally told me that I need to from python.display import the module display. Classic mistake. So if we try this again. So now this should work. Yes, perfect. Okay, so head of that is going to be the top 5 entries, and let's do the same here. So let's compare. They should all be flipped. Yes, correct. So these are all minuses in the new one. These are all pluses in the old one. So that's progress, at least here. So let's do this for each of those. Let's only do it for scanner 1. So let's scanner flips. Let's make a list of those, and scanner flips. We want to append the flip. Maybe I can say flip or flipped. Flip is going to be our data frame. Yeah, what we did up here basically. This one here. And instead of 7, we're gonna put actually just flip. So this should create for scanner 1 a bunch of alternatives. So let's check that one. So scanner flips. It's going to be a bunch of okay. Wait, what's the length of this? 8. Okay, yeah. So we have 8 different versions. Yeah. So if I take each one just for an example, let's take number 6 for example. We see it's a version of our scanner 0. And now to print it, we will also need the extra information we add later, which is the the scanner and size. So what I'm gonna do is after this is flipped, I'm gonna be concatenating this flipped with the rest of the columns of this scanner as they are. Okay. So actually, we may want to rename. Um, hmm. Yeah, we may want to rename the scanner so we can tell which flip we are performing. So instead, what I'm gonna do is convert the flip into a string, um, and let's see, how this. Let's test this outside of here. Oh, perfect. And if I multiply this by 10, it's going to look like this. But then I can do it like this. Yeah, yeah, that looks correct. So we want to multiply it by the number of dflock, the number of dimension, or like the length of the scanner readings here. So let's take shape 0. Right. So then this one will always match. So basically, this is going to be the name in our plot further here. Instead of having 0, 1, 2, 3, 4, now we're going to focus on scanner 1, and we're going to create these alternative flips just to get some intuition on the problem, because it's becoming a bit dense. So let's see. So we're going to replace this one here with what we just created, and we also need to just do this as well. So we need to create this. Sorry, this one. Yeah, we need to create again the size column as well. Oof, that's also dense. Let's make it a little bit nicer. This. Why not? This one ends here. And we want to save that. And we also want to be axis 1. Let's not make this mistake again. And we want to save it as flipped. Yeah, we want to override flipped with that. So let's try this again. Okay, it failed for. I can't. Okay, but it's fine because this is a string. It doesn't like it, but that's fine. We can make it into a series. Since it's a string, it should be no problemo. So we're gonna give it a name. It's going to be scanner, and then we're gonna do the same df series here. We're gonna give it a name, and that's going to be size. And now that should work. No, data frame object has no object attributes. Yeah, sorry. Wow, that was easy mistake. PD, not df. Yeah, pandas series. So let's see how this looks. Oh no. It's not a value anymore. Not a number anymore. Let's see. I messed something up. Let's try to go run everything again to fetch our original data. Create the orientations. Put them in a nice loop. This delete though that here we don't need it. No, we still destroyed the oh, what is this? Oh yes. Or okay, I think I know what happened here. It's trying to fix the. Can I forget? Can I just forget the index? Index. Because it's trying to concatenate them with the index keys. Multiple keys are past levels. No names. Integrity. I suspect that this is the problem. Ignore index. Yes. Perfect. Ignore index. And that's going to be true because we don't want the index. So now that should look correct. No. try this one more time. We have the coordinates. Okay. That should. So what's the? Yeah, we concatenated. So I suspect that something of those fellas here is messing things up because they are concatenated just fine. Maybe what we could do is to make sure that there's no index here. Drop the index and in place. Let's see. Up. Oh, yeah. Oof. Okay, I messed up. Yeah, I see now. You're bad. So what we're trying to do now is I've created the. Oh no. No, that doesn't give me anything at all. I've created the an array so I can loop through nicely without having to manually do this. So basically what this does is it multiplies each column with 1 or -1 depending on what kind of orientation flip we wish to do, so that we don't have to do those manually. And the reason for me to do this is because, and that's only for scanner 1, and the reason for me to do this is because I want to print all the different, or like plot all the different orientations and see if it makes any sense that they eventually match a little bit. Oh well, I scrolled a bit too much. Let's see. All right. But for some reason now. Oh yes, I have to. Sorry, that's the mistake here. The in-place argument does not return anything. So basically, even though we reset the index, when we do it in place, it doesn't return anything. It does it directly on the object itself. But in this case, we need to return something. So that was the mistake. So that should work now. Yes, perfect. There we go. Ah, finally. But now we lost. That's still fine. We lost the column information, but I can fix that. That's an easy one. So we can say flip columns is equal to x, y, z, scanner, and size. So then I don't even know why I had to set them here since they disappeared. So let's go back at that. Perfect. So great. So now that we have this, I can comment this out. We need to plot it. So let's do this. So to do this nicely, we need to concatenate all of them on top of each other. So we'll do the flipped. Actually, I can just pass flipped here since it's a list. Axis 0. So we want to concatenate them on top of each other. That did not work. The first argument must be an iterable pandas objects passed. Yeah, sorry. Scanner flips. Yes. Okay, so that's now. Oh, and I see it has kept. That doesn't matter. But and then I can do ignore index true as well. Perfect. So now this is only the scanner 1 and it's just flipped in different orientations. So we got that. Um, and we want to append to that. So actually, I'm gonna do it. I'm gonna do it here after it's over. Actually, not even here. Up here, what I'll do is I'll add the scanner 0. So we can take this. So we have scanner 0 as well. Let's perfect. So that should look okay now. No, I still took scanner 1. Sorry, scanner 0. Yeah, perfect. So now we have in this data frame here we have scanner 0 and scanner 1 in 8 possible orientations. So let's save this as df flip in df. Let's do this and let's make this just show the head of it, like the top of it, and why not. So let's change this into flipping df and it should immediately work. Indeed. Okay. Am I smarter now? Probably not. Let's see. How can I? Yes, perfect. So let's test them one by one, I guess. I mean, there is okay. This is totally, or this is totally not right. Okay, so this, but that we knew because that was the unchanged coordinates. This is flipped on the y-axis, and let's see. I can't say I see something obvious. I mean, the best way to actually do this would be to somehow calculate the distances between the closest objects. Or I mean, we can take all the pairwise distances, but that's gonna produce a lot of distances. So let's remove this for now and go to this one. Any overlapping ones? Yeah, so I think I think the way I'm looking at it now is also not going to return any results because now we're putting all of them in. They're all like in the same frame of reference. But in reality, it's more like this. They just overlap in some regions. They don't overlap in the entire region. So, Ah, wait. No, well, that seems pretty quite. Maybe. Yeah, maybe those down here. Can I? A little bit. Do they seem similar? This is no. This is like Where's Waldo, advanced version. If I just completely have it like this, will I? No, I won't be able to like overlay them nicely. Okay, maybe that one is not either. Let's take this other one. Some hope. No. Ah. Okay. Seems to be something down here. Depending on where you look at it from. There is some potential in this one, maybe. I feel like I'm chasing ghosts now. So that's the light blue one. So if we just inverse the x-axis, we might have gotten something. But still, the biggest problem now is that mm, that they are all in respect. Let me think. Hmm, because they are all centered around their own scanner, but in reality, they should be. They are more like this. Um, hmm. Computer science is hard, man. Um, that's probably like l- could be a pretty standard. I hope it's not a pretty standard problem actually. That would be very demotivating. But it's quite dense actually. So because yesterday I did the 11th one, which was quite fun, but that was cellular automata, and I kind of played with these kind of automations in the past. I feel like this one here is really kicking me out of the water completely, like intuition wise. Your bird is laughing. Okay, I get you. Um, but I mean, there is probably a very elegant and nice way to solve this. Um, and I've tried two ways, of which both. I mean, I haven't finished this one. Now it's just visual inspection to just get some brainstorming done. But I think the problem I have right now is that um, I need to figure out a way to perform like a search like this. And you know, when you say search, it's always like some sort of uh, computer science algorithmic problem that is solvable with some by just knowing some like certain algorithms. Um, so I wonder if I can do it without that knowledge. I mean, I should be potentially given enough time. I mean, eventually, but we don't have enough time actually. I have to go. Yeah, what time? Yeah, I have to leave fairly soon. Um, so I think that's going to leave you empty-handed again. I'm probably gonna close the stream in 5 minutes, maybe get some time to change and get ready to go. I'm gonna go help some friends move out to their new house. Uh, get some workout done. Um, then gonna have some nice hangouts. I mean, it's a Sunday evening, or it's not even evening yet. Damn it, Sweden! Always confusing with the darkness outside. Um, how's the weather in Gothenburg? Do you have snow? It's like it was pretty cold today here. I went for a run earlier, and um, it was pretty cold. It was minus something, -1 or 2. Uh, but it felt nice. Let's see. Yeah, I don't think I'm gonna be able to nail something in the next 4 minutes. So maybe I can just. Sadly, no snow. Oh, well, hopefully we'll see some white Christmas. At least there's a week left. We need some snow. We need to have ski plans. We can't not go for ski. Mm. No, it's snowing the next days. Yeah, let's see. Like, what's the weather? Oh no, I usually use this two websites. It's at SMHOI. Cold winter this year. Oh, that would be pretty cool. Väder i Göteborg. But then it says Stockholm. Well, you got played. Let's see. 10 days. Um, Give me some snow. Wow, it's gonna be sunny on Christmas Day. Also, how sad it is that Christmas falls on a Saturday. No, no vacation days this year. You have to take everything. Um, Ganska säker. Okay, it's pretty certain. Okay, interesting. Not so certain for these ones. Well, how can you be uncertain for like days in between, but then really certain for days afterwards? That's pretty interesting weather model. No snow. Well, it's a lot of. Oof. I didn't notice that. -10. Nice. So then it's going to be cold, but uh, cold relative to our new global warm standards. So true. Yes. Can't wait until Stockholm becomes Athens. What is Gothenburg doing in the next days? It's probably Göteborg. No, that's the general search. No, I didn't want to do that. Sorry. Göteborg. Oh, there is some snow and rain on Tuesday. Yeah, same. Oh, but you have 10 degrees warmer on Christmas Day. Also very certain. Okay. No. Um. Yes, Athens. Yeah, Sweden is going to be like Sweden has so many islands. I think Sweden has the most islands in the world, so it's going to be the best place to have the Aegean Sea #2, but better. There's like all these islands. You can have your own island, and it's nice and warm all year round because we fucked up this planet. Um, yeah, and I have the no, I think that's the Norwegian website. I always check both of them because, but underwater soon. Yeah, well, hopefully we're working on it. Let's see. Maybe if we make like everyone tries to do a little bit of green things here and there, company wise. I mean, I'm not sure how much impact each individual can have really, but there is a lot of push for green energy, and hopefully, eventually we will reach highs and not as highs as predicted. Hopefully, let's see if we manage this. It's up to us, I guess. Yeah, it looks pretty similar. It is more sophisticated. I guess we can have a podcast for that next time. I'm gonna head out. Thank you very much for tuning in, Nico. Always nice to see you. Hope you're having fun down in Gothenburg. I'm gonna be probably doing those completely irregularly. And I also did this. Wow. I have a new camera. Yeah, I'm gonna see how this setup is going to work. But once in a while, I'm gonna be popping in for some random things. Have a great evening, everyone. Enjoy and have a wonderful Christmas week. And Merry Christmas if we don't see each other. Bye bye.